So with Unreal Engine open, either open a project you already have, or if you have to do a new project, just choose the third-person example map, or third-person example. Okay, YouTube's now live. So refresh the YouTube page, .WorkGames, and look for the video that says live now. That's my screen, and we're gonna get started. Any last questions? I just had one question of a specific topic to cover. Other than that, I'm going to cover my own topics. So any other questions you want me to cover? How babies are made? Anything at all? No? All right. No, you had your chance.
How do I get a girlfriend?
That is a multi-week lesson, sir.
We can cover it.
I learned the amount I can learn in a week in about 3 years. So
Good. Okay. Next lesson, when I'm back on Friday, we'll do how to get a girlfriend, okay? Remind me. Okay, I can't just be good at game development, right? All right, moving on. Okay, so today I'm going to show you actually stuff from my own video game. I was asked some really good questions this morning, and that's the lesson I've been going with. So everything's in the live stream. We're getting started. I'm going to cover the options menu either toward the end or somewhere in the middle of this lesson. I think a lot of the lesson today is going to be abstract. What I mean by that is you'll be able to enjoy it and learn a lot from it without having to follow along exactly. So excuse me back there, if you're going to not use this time to learn, that's fine. You're wasting your own time, not mine, but I don't want you distracting other people. So just keep the talking down, the laughing down, the Fortnite down. And for those of us who want to make games, not just play them, let's get started. Okay, so my game is a strategy game. Somebody this morning asked me, how do you make a strategy game? It's a great question. First of all, what is a strategy game? Checkers is a strategy game. Do you want me to show you how to make checkers? Probably not. You know, usually when people talk about strategy games, they really mean something known as a real-time strategy game. Real-time strategy game. And the main difference between a real-time strategy game and a first-person game or any other type of game, horror game, etc., is a real-time strategy game is a simulation game. And what that means is it simulates through systems that work autonomously on their own, but the player can influence or change. All right, that's a lot to kind of think about, but I'll show you an example just for this. So right now we're looking at a testing map, okay, a testing hall, and there's no mountains or anything in the background. It's not meant to look pretty, but it's got things for testing and various stuff, right? So I've got these people here, okay, and they're just an Unreal mannequin, just like you're used to seeing. I can click on them, right? And what they're doing is they're actually going to these homes. So they go inside the home, and then they're going to leave the home, and they're going to go to work. Okay? They get assigned a home, and they're going to continue doing that, regardless of what I do as the player. These guys are just standing here, though, because they don't have a home, right? They haven't been assigned one because there's no more homes available. So what I would do as a player is I'd build a home. So I'll place some homes in landscape here like this. As many as I'd like. And when they're finished being constructed, these NPCs are going to go get assigned to a home and go to their house. Okay, so they get assigned there. And the same thing works as far as working. They'll get assigned a job, and if there's no jobs, well, then they don't get assigned. And here this guy is going to his home because now it's finished, and he knows where it's at, he knows how to get there, and all that sort of thing, right? And this guy too. Okay? So this is a simulation environment. There's also other things like if they get thirsty, they have a health attribute or thirst attribute or something. They are going to go seek out a well if their thirst attribute goes below 40%. They're going to find a well and actually go to it, drink from it, restore, and then they'll go back to working and doing the normal thing. So the strategy aspect, or I should say the real-time aspect of the strategy game, is this fact that this simulation goes on regardless of what the player does. But the player can affect it by doing things like building a house here, building something there, somewhere for them to work, etc. Now, as far as how does all this work, the kind of cool thing about this is if we take a look at that NPC, right? We go over down here, we open up one of these NPCs, it looks like the Unreal Mannequin and everything. Go into his event graph, there's almost no code on the event graph. In fact, all this code is basically not even being used. This is just the code that comes copy-pasted when you start, when you use a third-person character. And then this isn't even being used. The event tick here, which looks all fancy, is not even connected. So none of the code, there's only one little code that's working, which is this part that sets their speed to be a random speed. So some are walking, some are running to the locations. Where's all the code telling them to go to this house, or to go to work, or to go look for a well when they're thirsty, and other things that they do? It's actually on what's called a component. Okay, if you look in the details panel, or components panel on the left, I have something called NPC behavior. This is a component that I add by hitting add component, right? And I created this component, and this component is where all the code lives for the NPC. I didn't put it on the blueprint, the coded object of him himself. I put it on this specialized component thing. We'll open up the component looks like. Okay, there's his code. There's the actual code for the NPC. No viewport for components, okay? They're just like an event graph. They can have functions and custom events, but they have nothing physical to them that you can see. The advantage of working this way is rather than locking all of my code to the NPC here, I now have this thing that can be added to anything. And the advantages of that will become probably abundantly clear in a few moments. Taking a look at NPC code, NPC behavior, okay? I have various functions, for example, one right here called get. This is a custom event, right? Right click, type in custom event, so you make those. And it's called get nearest actor to me and send me there. I like to name these events really literally exactly what the code's supposed to be doing, because that helps me when I read it, you know, without even seeing my code, what it's supposed to be doing. Get nearest actor, actor's a thing, to me, that's whoever's running, whatever object's running the code, and send me, the thing running the code, to that thing, to the nearest actor. And that's what all this code does. Now what's cool is, well, okay, so this is the code, by the way, that's run when they get thirsty, they go look for the well, okay? They get thirsty, they go look for the well. But you'll notice there's nothing in here that says anything about a well. I'm not, and I could, but I'm not saying, hey, get all the wells in the world and find the nearest one and send them to the place. Instead, I'm just saying, give me the actors in this list. So the input that's coming through is something called actor, the most generalized blueprint type of code thing. Okay, actor is just a thing. And it's saying, give me these actors, send me to it. And I can call that custom event with something like this, and I plug in the actors I want. Okay, remember, actors are just things. And it takes in a list of whatever, and then it will find the nearest one and send them there. Designing in these terms allows me to say, hey, get all the nearest tax collectors, send them to the tax collector. I mean, you can do anything. Get all the nearest coconut trees, send them there. You know, send them to the nearest one. This is a generalized function, event, that can be used for virtually any purpose, and it's not exclusive to wells. So I don't have to rewrite this code ever again. Whenever I need an NPC to go to something, I can always just call this event, send him a list of the things I want to get to him to look through, and he's going to go to the nearest one, near to him. So this is really cool because you write the code once. Yeah, it's a pain to write. It's complicated to write. It's a lot of bug fixing. But then it can be used infinitely from there. I'll give you an example now. I'm talking about how this is a component. Component can be added to anything, any blueprint, okay? If I want this lone statue over here to be an NPC, right? For it to be an NPC and go to work, I click on it in details panel, hit add component, type in NPC behavior. Boom, it's now an NPC, okay? And I want it, and then I have some things I can change about it, like my NPC has different variables, occupation, for example, farmer, temple priest, gender, the widget, the menu that comes up when you click on it. I can set all those things for it. But I just added a component. Now this thing has all that functionality. So it's not tied to this third-person character anymore. Instead, it lives on the component. The component can be added to anything. All right, an example of the advantage of this. Let's say on my NPC behavior, I have an event called NPC Wander. Okay? And all NPC Wander does is an event that tells the NPC to wander around the world. Just wander. Okay? And maybe I want to fire that sometimes. Like, yeah, when the NPCs aren't working, they just wander. Now, let's say I want to put some dogs into my game, like stray dogs that kind of run around the world. Okay? I could go in there and make a blueprint for the dog and code it all and do all that stuff. But by doing a custom, this component thing, all you do is put my dogs in my world and make my dog blueprint, add the NPC component, and then check mark, a Boolean called wander. And then the dogs wander around the world, and your player doesn't know the difference, okay? But you coded one system meant for NPCs, and now I can add it to dogs and hippopotamuses and deer and whatever, and they're doing those things. And as long as I have a way of check marking on and off, like so they don't go to work, so you don't have a dog going to work or something, then you're fine. Then you're fine, and you don't have to code anything. So this idea of coding systems then will be extendable to you later. Okay. What time do we get out of this class? 13? Okay, so we got like 10 minutes. Let's show you a system, kind of a neat system for building things, the montage that the player sees. Okay, so what does the player see when you build something? So this is something that I iterated on forever and ever and ever, and it's been replaced and built and replaced, and finally I'm in a place where I'm happy with it. I'm going to show you this now. So watch either on the screen or the live stream what it looks like for me to build, for example, a statue. So player presses down a statue, and this is what happens. Okay, a lot happened there. I'll do it again, and you can see. Place a statue down, block of stone, and scaffolds spiral upwards. This guy is now hammering things, being chiseled out of the stone. Blocks remove the sand from the statue's face, peels away, and boom, it is then left in its place. So how is that scripted from a coding perspective? Well, I'm about to show you. So again, all these appear. Okay. What does it look like in a blueprint? It all starts with this. This is called the building under construction blueprint. All right. This has all the code for it, and everything else that derives from, I should say everything else that, I'll explain this. Well, there are parent blueprints and there are children blueprints. Okay. When a blueprint and another blueprint love each other very much, they get together and they make child blueprints. Right? You make a child blueprint in your content browser by finding the blueprint that you have all the code on, basically, generalized code. You right-click and you hit Create Blueprint Class. So my parent blueprint for my construction system might look like this boring cube here, but this is the child blueprint for which I add all the specific stuff, okay? And this is what that statue looks like, okay? So what's going on is I have all these static meshes, and these static meshes are told to appear and disappear like every 0.15 seconds or something, so really rapidly in a certain order, and through something called a for each loop, which basically takes in a list and turns them all on, off, on, off, on, off. And what's going to happen is that's going to make them appear. They were always there. When I placed the statue down, those static meshes are there in the world, but they're not, their check mark is hidden in game. And one by one, we set them to true, 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 setting them to visible, 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 right? And then that's what's going on with the scaffolds. And I do the same thing with the carving effect. So the carving effect is you have this one block of stone. It's actually made of these several blocks of stone that are just snapped together, and I can move those out. And those are all set off in a certain order. And underneath, you have the actual carving of the statue always sitting there. But wait, then there's another trick, which is you have this statue here, but I actually have two. Okay, I have the final statue that you see as the player being built, and then I have this right here. And this is a slightly larger statue than this one. And by being slightly larger, it's the same exact statue, just the material, right? The textures on it are different. It's like this rough stone material. By being slightly larger, it over-encompasses this. And what I do is using something called a timeline, I take its size and slowly shrink it over time, which as it recedes into this statue creates the effect of the sand being scraped away. For the props that are appearing here, these appear one by one in terms of milliseconds too. They're the same system that does the scaffolds and everything else appearing, the blocks disappearing is controlling that. And then you have this guy, this animated character here. How is he spawning in different locations when he spawns? Well, I have a series of these waypoints, which are just these scene components, which are just something you can add as a component, add a component, type in scene. All it is an empty thing, but it has a location, which is useful. And I put the different scene components in different areas of the construction site that I want them to appear at. And then I have a custom event that sends them to that location. Okay, so that's that. And then finally, what happens at the very end of this being constructed, the very, very end, what ends up happening is the construction itself is, the construction site is deleted actually from the game, and spawned in the same location is an empty blueprint actor that has the same building mesh as that statue or whatever it is I'm building. So it's actually, there's a kind of a sleight of hand magic trick going on is once this building completes, it deletes itself and you spawn a new building in place of it. But since it's in the same location, you don't notice that it's gone. So now, and there's particles and stuff and everything spawning. But now that you've seen that, we're going to build that. And now you know exactly how that works. All right, I know that was a short lesson. I will be back Friday, so think of ideas. I didn't cover the options menu screen, but we can do that Friday for sure. It's a great question, great thing to cover. Thank you guys for being quiet. You guys are a really good class. Appreciate it very much. All right, 3 minutes.